demonstration is about performance analysis of electric vehicle using Arduino based BMS. Under the guidance of D. Balaji, Assistant Professor, Tribri, where team members are Abhinaya, Chitra, Ramya.
So as EV is going to be the near future and it is going to boom over the upcoming years, our project is on the EV system and we take a project in the real-time issues of the EV. So in this project, the main power supply is from the transformer of 230 volt, which is a step-down transformer, and from here it is input through the voltage regulating power supply board. Here the three mode of action tend to be taken place, which is rectification and filter and the voltage regulation. From here the 12 volt AC gets converted to DC, and through the voltage regulator it is converted to the 5 volt, and which is inputted to the main power circuit of Arduino UNO. And from here the power is inputted to the various power channels. Here is the two electromagnetic relays, which is the main thing to charge the battery using the two modes, which is the fast charging and slow charging mode. Here is the LCD display, which is 16 byte LCD display, which is used to display all the parameters like voltage, current, temperature, and SOC and SOH calculations. Here is the audio alert through the buzzer, and this is the lithium-ion battery, which is 3000 ampere per turn with 300 cycles. And here we stacked the battery in series connection, with each has a 3.7 and overall of 12 volt. Here this is the cooling fan. In order to cool the battery whenever it is get heated, and this is the geared DC motor which acts as the load, and this is voltage sensor in order to sense the voltage of the battery, and this is the current sensor which is used to sense the current of the. So initially we have to reset the system. Once we reset, the system is displayed as welcome to BMS, and the parameters tends to be displayed. So SOC and SOH is 0. Here it is minimum voltage. So it displays the low battery voltage, as the system has 7.8 voltage, which is lesser than the threshold. So the buzzer tend to be turned on. Once the system is measured with the low voltage, we can able to charge the system with these two charging modes, which is fast charging, by which the charge can be charged in a fast manner. So you can see here, slowly the system voltage getting rise. So once it attains the threshold range, the buzzer tend to be turned off. And then is the current monitoring. So in order to measure the current of the load motor, so we turn on the switch. So once the load gets operated, the current value tends to be monitored over here. So here it is 816.50 milliamps, which is almost 1 amps. So by which the real-time current monitoring can be measured through this visual display.